Okay, so this is part 2 of multiplying rational expressions. Once it starts looking this busy, definitely want to make sure we are factoring first. So factoring's not going away. I'm going to look at my terms here and decide, okay, what am I going to be factoring? So x plus 9, it's just x plus 9, so I don't have to do anything with that. X plus 10, I'll just put that in parentheses. I know it's already locked in, I don't have to factor that. But then I look at x squared plus 19x plus 90. Definitely looks factorable. I gotta think, okay, do I have a GCF? No, but I have 3 terms, so that means the x box. So I'm looking for factors of 90 that add up to 19. So numbers that multiply to 90 that add up to 19. Right off the top of my head, it's like 90, so it's 9 and 10. And then I go to the box, and I'll get first term in the first box, so that's where the x squared comes in. Last term in the last box, that's the 90. And then the numbers in the x, the 9x and the 10x, get added. And I'll find the GCF of x squared and 9x, just x. And x times x equals x squared. And then x times something gives me 9x squared. It's x times 9. And then x times 10 gives me 10x. So the numerator for that guy, I'll bring over the 9, x plus 9 over here, and the x plus 10. And so I'm just now writing this guy in factored form, which is x plus 9, x plus 10. So hopefully that's going to be canceling with something. And then the denominator, it looks like 5x plus 45. It's 2 terms. So checking for a GCF, they both end in a 5, so I can take out a 5. So I divide 5x by 5, so it's x. 45 divided by 5 is 9. And now I'm canceling, so I'm moving from left to right. X plus 9 can only cancel with the x plus 9 in the denominator, so it can only cancel with this x plus 9, not the one right next to it in the numerator. I can only go canceling top to bottom. And then x plus 9 doesn't have another x plus 9, so this one has to say, because there isn't another x plus 9 that cancels, but there is an x plus 10 that cancels with an x plus 10. And here we go. All that's left over in the numerator is x plus 9 over, then I got to remember the 5. So that's our first fairly busy question, and we'll do one more. Okay, so this one has a lot going on. We definitely need to factor first. So what are we factoring? Looks like the numerator for the first fraction, the x squared minus 36. X squared and 36 are both perfect squares, and it's a minus. So that's a difference of squares. So it's x plus 6, x minus 6. Then the denominator, no GCF, but it's a trinomial, so that means x box. So it goes factors of 30 that add up to negative 11. So this is that special case. It's supposed to multiply to a positive number, but add to a negative number, so both of my numbers have to be negative right away. So 30 is 3 and 10, 2 and 15, 6 and 5. So I'm good to go here. And then I go to the box. First term in the first box, that's the x squared, that's the first one. last term of my trinomial in the last box, and then I take my numbers from the x. So negative 6x, negative 5x. So GCF of my first two is just x, so it's x times x. And then x times something gives me negative 6x. It's negative 6. X times something gives me negative 5x, negative 5. So that's just the bottom, the denominator here. So it's x minus 6, x minus 5. Looks like maybe we'll be able to cancel. We want to do that at the end once we've like factored first. Okay. And then the last little part that needs to be factored, x cubed just looks big. Like that's a high exponent. So x cubed plus 6x squared. They both have an x squared in common. That's my GCF. And then I get x plus 6 here. So it's canceling time. I'm moving from left to right. So I start with x plus 6. That'll cancel with this x plus 6 in the denominator. Then I move over. X minus 6 cancels with x minus 6. And I move over. 3 doesn't cancel with anything. But x, since these are kind of like separate things being multiplied, and so is this x squared, this x will cancel with this x, leaving me with just 1x in the denominator. Because it's kind of like having what we started the chapter with, 3x over x squared. What we would do is cancel and just get 3 over x. So that's the same idea up here. And our final answer, the 3 wasn't canceled out, and an x, loose x, and then x minus 5. So that's my final answer.